practical example of aerial photogrammetry with drone combined with terrestrial photogrammetry. In this example, data capture will be carried out using a drone equipped with a camera, followed by a series of flight missions with the help of the free mobile application Pix 4D Capture. The equipment for this mission will consist of the drone, its control controller, and the compatible smartphone or tablet terminal connected to the control controller. The processing of the photographic data will be carried out with the reality capture software. Data collection. Drones have become very useful documentation and control tools, equipped with an RGB camera, infrared or LiDAR. The drone used is a quadcopter controlled by a GPS controller with the help of the Pix 4D Capture smartphone flight app. On arrival at the flying site, it is important to carry out a ground survey to observe any obstructions at altitude. After making the necessary preparations and connecting the drone, controller and smartphone, the Pix 4D Capture application starts and we select the desired type of return. The white lines represent the flight trajectories. First, it is necessary to establish a height, in this case 30 meters, and then to delimit the flight area. The speed, camera angle and overlap are values that you have to rectify to obtain the desired capture results. They must be adapted to the element you want to capture and its environment. After editing the flight options, we proceed to start the mission and follow the program's instructions. As shown in the table, the altitude will continue to rise until it reaches 30 meters. Once the designated altitude is reached, the drone moves to the Start Mission Start position. Once the flight mission has started, we must visually monitor the aircraft and at the same time keep an eye on the panel of our terminal connected to the control commander. We observe relevant information such as mission duration, drone location, speed or altitude. The number of connected satellites is 17, on which it depends to geolocate the drone and fly more accurately. The icons depicted in the form of a camera on the grid indicate each of the photographs the drone has taken. Upon completion of the flight mission, the drone will proceed to its mission endpoint end and will automatically land in the same manner as it lifted off. Subsequently, we made a circular flight at a lower altitude to obtain photographic information of the elevations. We completed the aerial photogrammetric session with a selection of ground support photographs with the intention of completing and enhancing information not fully visible from the air. Processing. Reality capture. We add the total number of photo captures and in Alignment, Settings, we select Overlap High and then process with the Align option. We note that the program has not been able to link the ground and aerial data in the same point cloud, so it has split them into two separate components, each with its own point cloud. When we click on them, the images corresponding to each component are displayed. The images collected with the drone are georeferenced, so the georeferencing icon appears in its component. To join both point clouds, it is necessary to manually set homologous points to indicate to the program that both components are the same element. We proceed to segment the layout in 4 windows. We mark as information to represent in each one 2D, and we give a color value to each one. Control 1 blue, Control 2 green, Control 3 lilac, and Control 4 magenta. Select the option Add Control Points and proceed to search the images for clearly recognizable points and mark them on the different images. The spots should be easily recognizable, such as the apex of a letter, the source of a crack, or a well-defined and localized spot or dampness. An error is detected in the marking of control points, which is shown in the left-hand panel. We check the existence of this and modify it by gently dragging the point of the indicated image to reduce or correct the error. The photographic shots, the double grid mission at 30 meters, the circular mission at 20 meters, and the terrestrial photographic collection are represented. By clicking on the control points, it is possible to see the support cameras in the model. After having registered several control points, in this case 3, we make the link again by selecting the Align option, obtaining a single component and a single cloud of points, the result of the union of the two previous ones. The information of interest is the hermitage. Using the tool Set Reconstruction Region, in the Mesh Model panel, we adapt the processing box to the hermitage to obtain information about the delimited area. Once the processing environment has been delimited, we select the Normal Detail option to obtain the solid of the hermitage model. To make the texture with a better quality, we can select the model and apply the Unwrap option. Then we apply the texture to our solid polygonal mesh. Click on the Texture option in the Mesh Model panel to obtain our textured model and final result.